Hello, my name is Johnatan Ivanov. I am 21 years old and a senior at the University of Pittsburgh, applying to veterinary school this summer. Um, here's me. And today I'll be walking you through the uh, delta epsilon proof of the limit reached in step 25 of project 1 for Math 1020. I forgot to do this in the presentation, but here is the date timestamp on my computer. You can tell that it's 24 August 15th, and here's the presentation that I will about to give about finding the proof. So there you go. All right, as I said, this is the delta epsilon proof for step 25 of project 1 for Math 1020. So we're starting with this function, f of x equals rx times the quantity of 1 minus x, and we know that r is equal to 1.5, and then through iteration we found that x equals 0.33, or I will just refer to this as 1/3 throughout the remainder of the video. So we solve for f of x at 1/3, and we are greeted with 1/3 is the function of x at 1/3, at the value of 1/3. So then we can go about putting that into a limit and then proving that that limit exists via the delta epsilon proof method. So here is that limit that we are trying to prove, that the limit of f of x as x is approaching 0.33 is equal to 0.33, or in this case we can call that value L. So let's prove this using the delta epsilon definition of a limit. So the limit of f of x as x approaches any value L is that value L for every epsilon that is greater than 0. And there is also a delta that is greater than 0, such that the absolute value of x minus L, in this case that is 0.33, is between 0 and delta, which implies that f of x minus whatever number L, in this case 0.33, is less than the epsilon. So we go about starting our proof here, where we will set this inequality here with f of x minus L less than epsilon, and then we'll go about substituting in the actual function that is f of x, as we do here. And then we'll continue on, where we'll continue substituting now. We'll substitute the value of x for this value L plus delta. So 0.33 plus delta is now our value of x here in the inequality. And then this is just going about simplifying the expression inside this absolute value here. In the inequality, I don't have the the less than epsilon over here because I just kind of ran out of room a little bit. But once this expression is simplified out, you can get 0.5 plus the quantity of L plus delta times quantity of 2L minus delta. And then here, it's just another way of writing that out with the polynomial back here, featuring, these quantities multiplied out with each other. Then down here, it's just further simplification. We're just kind of bringing this to a close, taking out, the values that we can, and we eventually end up with this expression, which again is still inside this absolute value in the inequality of L, or 0.33 plus 1.5 times delta times the quantity of 1 minus delta. There should be another little parentheses there. Sorry about that. Anyway, so we continue with this, and the inequality now becomes this value here, where we'll get L plus, well, the expression that I just said, and then we're putting that back into the greater scheme of things, and we still have this minus L over here inside this inequality, which is less than epsilon. Again, we simplify even further, and then now here we'll approximate, just because this value delta is negligible, we can just set 1 minus delta simply equal to 1. And then that will finally bring us to the almost to the finish line, where we'll have the absolute value of 1.5 times delta, which is less than epsilon, and then we're going to solve, quote unquote, for delta, and then we'll finally get this value of delta is less than epsilon over 1.5. So thus, if we can choose to set this value equal to epsilon over 1.5 for delta, we can satisfy the definition of the limit. And again, sorry that we got a little cut off over here, but we can get this statement that thus, if delta equals epsilon over 1.5, such that, this inequality that the absolute value of x minus 0.33 is greater than 0 but less than delta, that will imply that the function of x minus L, in this case 0.33, is less than delta, and then that proves that the limit of f of x while x is approaching this value L, 0.33, does in fact equal L, the value of 0.33, since that we have proved that the expression is less than epsilon, and also in between the values of 0 and delta. Right? That was it. Thank you very much.